We have talked about writing equations with variables on both sides, but today I want us to look at variables on both sides types of equations and what that looks like in a table and in a graph and how we can find that solution in a second way and what that solution means. We talked about that a little bit a while back, but I want to focus just on that today. So today we're going to look at Harry and Ron, and then we're also going to look at Optimus Prime and Megatron. So it says on January 1, Harry and Ron decide to start saving money for their weekend visit to Hogsmeade. In the beginning, Harry has $300 in the bank. This is a B, we know that. And he plans to save $15 a month. So this is our M. Ron has no money, so his is a B, and he's going to save $75 a month. Here is his M. So what I want us to do is I want us to take that information and I want us to fill out this table and this graph. You can see here we have a space for us to write our equations. We're actually going to do those first, and then we're going to apply and find some information. So I want us to write our equation first for Harry, and we know that he already has 300 and he's going to save $15 a month. So we can write 300 plus 15x equals y. And then for Ron, he has no money, so his is going to be proportional, and he's going to save $75 a month. And now we can take that information and we can use our calculator, either the one that we downloaded. You can also use just the one on your phone if you prefer. It doesn't really matter. As long as you have a calculator, it's going to make life a little bit simpler for you. And we're going to fill in this table. So we can go 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And we know, based on our words and our equations, that Harry, before we even start, has 300 and Ron has none. So if Harry is going to save $15 every month, then he is going to have 315, 330, because we're just adding 15 each month, 360, 375, 390, 405, 420, 435, 450, 50, not 15, sorry about that, 450, 465, and then what is that, 480. Okay, so by the end of the year, Harry should have $480. Whereas Ron, he had none to start with, so then 75, we can do 75 times 2 is 150. And again, if you wanted, you can use your calculator. 150, what is that? 225, 300, 375, 450, 525, 600, 675, 750, 825, and then 900. Okay, so this is January 1, and then this would be February 1, March, April, and so on. So now we've got this beautiful table, so now we need to make a graph. And you can see here that it already has a scale for us, but we do need to make sure we put our variables. Remember, months is going to be X and Y is going to be money. So we're actually going to have 2 lines on this graph. So we have months, we need to label months and money. And we can continue our scale. I've already started it for us. 4, 5, 6, 7, 8, 9, 10, 11, and 12. And they want us to count by $50. So on some of these, we're going to have to estimate in the middle. 100, 150. So we're just going to get it all set up, and then we can graph our lines. And I am going to show you how to do this also in the calculator to check your work. 500, 550, 6, 650, 7. So we're not going to make it all the way up to Ron's 900, but that's okay. So let's graph Harry first. So 0, 300, and then 1 and 315. We're just going to have to kind of guesstimate that. And then 330. It's a little bit higher. 345 is just before the 350. 360 is just above it. 375 is halfway between 350 and 400. 390 just almost to 400. 405, 420, 435, 450. And it's kind of, this is not the scale I would use, but it's not bad because Ron's is bigger and we want to put both of our numbers on here. And then we've got this. Okay, and we are actually going to leave these dots because this is discrete data. He's only saving it once a month, so it doesn't make sense to connect the dots to figure out how much money he has in 3.5 months, okay? I'm going to use a different color for Ron so we can see that. So Harry is in regular pencil. I'm going to go ahead and use red for Ron. And he had no money, so we're starting at 0, 0. 175 is in between 50 and 100. 2 is 150. 3 is 225. 300. 375. You can actually see in your table there. So that dot's going to overlap, and that's okay if they overlap. Then we have 450. 525, 600, 675, 750, and that's as high as Ron can go. Okay, so we can see the two different lines. If we wanted, we could even mark them, especially if you don't have two different colors, Ron and Harry. Okay, I do want you to be able to look at your calculator. So I want to show you something new in your calculator. So both of these are in y equals. We can actually graph these to check our graph. So I'm going to hit the y equals button, and I'm going to type in this equation. Your x is going to be right here below the mode. And then I'm going to arrow down, and I'm going to put in Ron 75x. I'm going to hit enter. Actually, no, I'm sorry. We're going to hit graph up here. And we can use our fingers. So here's my 0, 0. We can use our fingers to spread out the scale. You can see right there, there's Harry's going through the 300. And you can see, in fact, that, and they used red, which is Ron's line, and you can see that the red line is steeper than the blue line. So we did a good job there, okay? You can also see here that they intersected, which is where we intersected here, okay? So you can check your work that way. Will Harry and Ron ever have the same amount of money at the same time? Well, yes, we could see that here in the table. We could also see it here in the graph. So we'll say yes. If so, how many months will they have the same amount of money? Well, that was at 5 months. And how much money was it? It was $375. And you can see that here in the table or in the graph. Who would have more money to buy Hermione a Valentine's Day present? So Valentine's is in February. So we can see at that point, Harry has $315 and Ron only has $75. So we would say Harry. Who would have more money to buy 4th of July fireworks? So we can come up here. So March, April, May, June, July. Right? So in July, now you can see that now Ron has more money. So we'll write Ron there. You can also see it in your graph, right? So July was month 6, and his dot is higher than Harry's. February was 2, so you can see here Harry's dot was higher up than Ron's. Who would have more money for their favorite math teacher at Christmas? So August, September, October. Already had August, we're not going to have August twice. November, December, and this would be January the next year. So we can see here that Ron does have more money. And on that one, we would want to use the table because our graph does not go up high enough. Okay, so that is how you can use your calculator. You can also, when you put in your equation in your calculator, you can, so we're going to close it. Table is right here where graph is also, but it's tiny. So that means we need to hit this second button, and now table is blue. So you can also use this to check your table, where this would be Harry and this would be Ron. And you can check your numbers with what we have in our table. So just a couple of things you can do. I'm going to have you pause the video and go ahead and try Optimus Prime and Megatron on your own, and then you can unpause it and hear my solutions for that, because I do want you to try to do this on your own. So welcome back. Optimus Prime challenges Megatron to a card chunking contest. Because Optimus Prime's card chunking ability is faster, he gives Megatron a 4-car head start. That is Megatron's B. Megatron can chunk cars at a steady rate of 4.5 cars a minute, and Optimus Prime can chunk cars at a steady pace of 66.5 cars per minute. So again, let's write that equation. So 6.5x, and Megatron is 4.5x, but he has a 4-car head start. So again, if you wanted to, you could do the math, or you could go through and use your calculator as we did before. So I'm just going to clear out both of these equations, and I'm going to write my new one, 6.5x, and my second one, oh, I put that in the second one. I did not mean to do that. Let me fix that. 6.5x, 4.5x plus 4. And I'm going to go ahead and I'm going to use this table function. Now you'll notice that we're starting way negative. We don't want to do that. So we're going to go ahead and go all the way to 0. There we go. So that we can fill this in. So 0 and 4. I'm going to go ahead. We got 6.5, 8.5, 13, and 13. Put a little star there, that's important. 19.5, 17.5, 26 and 22, 32.5 and 26.5, 39 and 31, 45.5, 35.5, 52 and 40, 58.5, 44.5, 65 and 49, 71.5, 53.5, 78 and 58. Now I do want to draw your attention to the fact that we did write our slope with a decimal. Putting it in the calculator makes that much easier. I would prefer that you write this 6.5, so 2 times 6 is 12, plus 1 is 13 over 2x. So for every 2 minutes, Optimus Prime can chunk 13 cars, and for Megatron, 4.5 is 9 over 2x plus 4. But that doesn't really make it very easy to fill out our table, so I would prefer this. But if you wrote this to put it in the calculator, that's perfectly fine, and to do your calculations. So here we can say we have minutes, because again, that was our x. And then we would have cars. And you can see here that they've decided to count by 1 on the minutes. They've already given us a scale to start with. And then 2 for the cars. And if we wanted to change that scale, we could. We're not going to be able to put all of these on here, but we'll be able to put enough to get the information that we need. All right. So we can see here, I'm going to go ahead and do Optimus Prime in red, and then Megatron in blue, because that tends to be our school colors, and why not? All right. So Y. So Optimus Prime, he's starting at 0, 0. I am going to do a little estimating here. 1 and 6.5, 2, and 13. So again, we're going to have to kind of